For this problem, we're going to be using Coulomb's law. We have a balloon that's rubbed against some denim and gains a charge of -8.0 microcoulombs. What's the electric force between that balloon and the denim when the two are separated by a distance of 5 centimeters? And then we're going to assume that the charges are located at a point and not all over the entire balloon. Now let's think about what's happening in this situation. We know that electrical charges are conserved. So if the balloon gains a charge of -8 microcoulombs, then we know that the denim must have a charge of +8 microcoulombs. So let's first write down what we know. First of all, we know that our first charge we're going to put down as Q1. That first charge is going to be -8 microcoulombs. Now let's remember what micro means. Micro is a prefix that means 10 to the -6. Our second charge is going to be +8 microcoulombs. And the distance between those two objects is 5 centimeters. Now remember that we have to keep our units matching, so we want to make sure that we have 5 meters, and we're going to convert that because we remember there are 100 centimeters in 1 meter, so we just divide 5 by 100 and that gives us 0.05. Now we're going to be using Coulomb's law for this. Coulomb's law tells us the relationship between charge and distance, and that will allow us to find the force. So the force is equal to our constant K, Coulomb's constant, times the first charge, times the second charge, all divided by the distance between them squared. Now K, that constant, Coulomb's constant, is going to be equal to 8.99 times 10 to the 9th. All right, so now we don't have to rearrange. Let's just substitute our numbers. There's our constant, our first charge. Now, our charges are the same other than the sign, so we can just square those, and then we square our distance. Now we'll get out the trusty calculator and enter our numbers. Now we're going to have to do something a little bit fancy with our parentheses to make sure that we get the correct number. We enter our constant, then use 2 parentheses, enter our number, to the -6 because it's microcoulombs, and then we're going to square and then close that with parentheses. Now we're going to take that and we're going to divide that by our square of our distance. And there we have our answer. Now 230.144, we're only going to use 2 significant figures, so it's 230. And that is a force, so it will be in newtons. So our electrical force is equal to 230 newtons. Thank you so much. Hope this was helpful. Bye, everybody.